If you see the typical structure of scanning electron microscope, it consists the source. This is the source. The source column contains that electron beam filament and anode. The anode accelerates the beam and then it condenser lenses. These are all electromagnetic lenses and an aperture to get that fine beam onto that sample. Then that to place that light rays onto that sample, that's objective lenses. We mold that we can turn the signal onto the surface of that sample, and this is the backscatter, and this one is the sample. This is the your sample. When light electron beam interact with the sample can generate that X-rays and secondary electrons and auger electrons and also backscattered electrons. These backscattered electrons will be detected by backscatter, the aperture, backscatter electromagnetic lenses which detect backscatter, and this X-rays means electron beam interact with the sample. The X-rays will be generated. We can detect with the X-rays with the X-ray detector. And here in the SEM typically we use a secondary electrons. These secondary electrons detected with a probe which has that scintillator. It's a scintillating counter we say that one. It counts that number of electrons enter into that one. This scintillation counter is connected to that computer what we use, and this scintillation counter is connected to computer nothing but a CRT tube. It's connected to the CRT tube, and in CRT tube we'll get that image and wave pattern of the sample. From this we can see the image of the sample in a structural form. This is the typical construction of scanning electron microscope. If you see that electron gun, anode and condenser lenses, below the condenser lens is the aperture, where we heard this aperture word during dispersive power experiment, and objective lenses to focus the beam, and backscattered electron to detect that backscattered electrons, and X-rays. And here in this scanning electron microscope we detect that secondary electrons. For the secondary electron detection we use a scintillation counter. This scintillation counter we use to detect the secondary electrons. From this scintillation counter is and backscattered, both are connected to CRT, cathode ray tube, and this is a fluorescent screen. Then fluorescent screen will give the image of the structural and topography of the sample, and means surface structure of the sample. This is a scanning electron microscope. We study the topography of the sample, structural studies of the sample.